We're going to look at lesson 13. Now you'll notice that I do something a little different this time. And I have you, you're going to be answering these 8 questions and uploading them in Google Classroom. So yes, there's a form. It'll have the video here and in the instructions. But for this, you actually need to do some drawings, draw some figures. And there's no way to really have you practice this without having you draw it and submit it. So I'll put a short video at the end of this lesson that will kind of demonstrate how you can take a picture and then upload it and turn it in as on your Google Classroom. Okay, so let's open up the slides for lesson 13. The first couple slides, let's go all the way to the diagonal line rule. So I'm going to explain everything that's in these slides, but I'm going to do it while I draw some stuff. So I'm not going to go back to slides as we do it. So you remember, we start off with energy levels, which are N. Remember this? And N, let's make this big. N can go from 1 all the way to 7. Now remember, with L, the highest it gets is N minus 1. So when energy level is 1, what's the highest your sublevel can be? The highest it can be is 0. And it can't get any bigger than 0 because it has to stop at 1 below the energy level. Let's go at 2. We can have 0 and we can have 1, and that's it. Right? So your sublevels, imagine that this is the name of the hotel, and the bigger the number, the larger the hotel is. So it can fit more floors. Here we only get to have 3. So our energy level is 3. So our sublevel is going to be 0, 1, 2. Here it's 0, 1, 2, 3. Here it's 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6. Okay, simple enough. So now the thing is, this is going to get confusing if I say that I'm at energy level 6, sublevel 4, and then I say another electron is at energy level 7, sublevel 3, 6, 4, 7, 3. All these numbers will start getting confusing. You want to know when we're talking about an energy level or when we're talking about a sublevel, which numbers go with each other. So what we have done is we've come up with this system for L where instead of describing L as a number, we describe L as a letter. So for L, what you do is instead of 1, you say S. Instead of 2, you say P. Instead of, I'm sorry. I don't want to confuse things here. Instead of 0, you say S. Instead of 1, you say P. Instead of 2, you're going to say D. And instead of 3, you're going to say F. There we go. So SPDF in place of 0, 1, 2, 3. All right. So what it will look like at energy level 1, we only get to have one sublevel, and it's sublevel 0, which we're going to call S. So at level 1, you only get to have the sublevel we call at 1S, meaning S because it's a sublevel 0, 1 because it's at energy level 1. Then at level 2, we get to have 2S and 2P. And then at 3, we get to have 3S, 3P, 3D, and 3F. And then let's go ahead and keep going. Here's what I'm going to do, though. I'm not going to go past F for any of these. So even though there's further sublevels that could exist, we'll just stop at F. 3S, 3P, 3D. Oh, I'm sorry. I'm just repeating the same thing. So we'll go 4S, 4P, 4D, 4F, 5S, 5P, 5D, 5F, 6S, 6P, 6D, 6F, 7s, 7p, 7d, 7f. Okay. Now here's the weird thing. This is called the diagonal line rule. And this is what we have right here on this slide. The way that you decide the order in which you'll fill these up is not going to be going from left to right like this. You don't go read it from left to right. You do a diagonal going from the upper right down to the bottom left. So at the beginning, everything's going to be normal. So here, down here, I'll write the order in which you'll do that. So we always will start with 1s. So 1s is the first sublevel you fill. After you filled 1s, let's do this again. You're going to go to 2s. Okay, no problem. And then it keeps on going the way you'd expect. 2p, 3s. Here's where it starts to get weird and where the diagonal line rule matters. If we go like this, we're going to pass through 3p, pass through 4s. So we'll have 3p, 4s. Notice we fill up 4s before we filled up 3p. I'm sorry, we fill up 4s before we finish off 3. So with 3, I'm messing up. 3 doesn't go to f. I'm sorry, guys. I'm sorry if that threw you off when I had that on there. 3 can only have S, P, and D. Okay, so we should still do 3D, but we fill up 4S before we do 3D. So when we're right here, it's going to be 3D, 4P, 5S. So 3D, 4P, 5S. You see that order? And it's a weird order. It would be hard to just memorize it, but when you're going and you do this diagonal line, then you can see it. So let's do the next thing. The next thing is going to be 4D, 5P, 6S. 4D, 5P, 6S. That's how you'll do it. Then we'll go 4F, 5D, 6P, 7S, 5F, 6D, 7P, 6F, 7D, 7F. I'm not going to continue all the way because honestly, guys, I'm not going to give you any questions that get this big. But this is how you'll determine it. Okay, so I might bring this up as we solve some problems in the near future. But that's how you determine the order in which you fill things. All right, now the last little detail I have to give you, if you might remember, the third quantum number is m, which represents the number of orbitals. And so the number of orbitals, remember, it was 2L plus 1. So when L is 0, which we call S, when we're talking about S, let's 0 times 2, 0 plus 1. So we only get to have one orbital. When the sublevel is 1, which we call P, 1 times 2 is 2, plus 1, we get 3. So at P, we get to have 3. When the sublevel is 2, which we call D, 2 times 2 is 4, plus 1 is 5. And when the sublevel is 3, which we call F, 3 times 2 is 6, plus 1 is 7. So that's bringing up what we did last lesson. But here's how I'm going to just shorten this. And this is just kind of, I don't think you'll need to think about this equation up here anymore because you'll just remember this because we're going to use it so often. S can have one orbital. P gets to have 3 orbitals. D gets to have 5 orbitals. F gets to have 7 orbitals, okay? So this is when your L, which tells you your sublevel, gives you your M, which is your orbitals. Now remember what an orbital is. It's just one of the things in the slides talked about the spatial orientation. Imagine an orbital is like a room that has 2 beds. So 2 electrons fit in each orbital. So 2 electrons fit in each orbital. So lastly, number of electrons, you can put 2 in each orbital. So if you can put 2 in that orbital, 1 times 2, you get to have 2 total electrons at S. You get to have 6 total electrons at P. You get to have 10 total electrons at D and 14 total at F. I know this might seem like a lot. We're putting everything together from last lesson and a new lesson. let me condense it all into the thing that really matters. So what we're going to do as we do these, S, so let's put this right here so you can see what I have on the edge. S can have 2 electrons at the most. That's how I'll write it as a little exponent. P can have 6. D can have 10. F can have 14. So just to understand what I'm doing, I'm giving you guys all sorts of detail, tying in last class's equations, but at the end of the day, this is the stuff you'll need to remember. And then the diagonal line thing. Remember, you'll have 1s, you'll have 2s, 2p, 3s, 3p, 3d. 3 doesn't go all the way to f. Don't make the mistake I made. 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f. And yes, you would have lines 6 and 7. For these next few examples, we're not going to go that far, so I'm not even going to bother drawing them. But this kind of puts it all together, okay? I know this is, it's a lot at once. Hopefully when I do this electron configuration here in a second, it starts to really clear up why I'm doing all this random craziness. Okay, so the last little detail before I do the problems. When we start looking at the periodic table here soon, I'll get into more on this, but you'll notice on the periodic table it's actually grouped so that you can be consistent. So remember we said that the S only has 2 electrons. So like this element, it's already filled up 1s and 2s has 1 electron. Right here, 2s has 2 electrons. Then you go 2p has 1 electron, 2, 3, 4, 5 until you have 6. Notice everything in here, a p the p sublevel is getting filled up with its 6th electron here. That's why everything in this column, they're called noble gases. They act a certain way. So this like everything about the periodic table is very organized and predictable, and we're going to get to that very soon. Okay, electron configuration is how we explain where the electrons are located. So hydrogen, what I'll do is when we do these problems, I'll say what Z equals, and that tells you how many electrons you have. So what we'll do, hydrogen is only going to have 1 single electron. So when we do the whole electron configuration for hydrogen, so we'll do it right here, hydrogen, where Z equals 1. Okay, well for hydrogen, remember what's first is 1s is first. So start with 1s. And how many electrons can an S fit? It can fit up to 2. But hydrogen only has 1 total. So do we need to put 2 in there? No, we only need to put 1 in there. So give it a little 1 up here, and it's done. That's the whole thing for hydrogen. There's your answer right there. 1s1. Okay, so let's do something a little bit more involved. Let's do neon, which is Z equals 10. So we have 10 electrons in neon. You might be asking why it's Z. That'll come up later. Just for now, just know that Z is going to tell you the number of electrons. Z equals 10. All right, so neon, Z equals 10. So we have 10 total electrons. So we're going to use the diagonal line rule right here and follow this. So first is 1s. So let's do 1s. What's the maximum that an S gets to hold? 2. Once you put 2 in S, it's full and it can't do anything else. How many electrons are we supposed to go through? We're supposed to get through 10. We haven't gotten through 10 yet. So what's after 1s? Another diagonal line. 2s. How many does S get to hold? 2. So put a 2 right here, and that's all we can fit. We have 2 here, we have 2 here, that's a total of 4. We need to use 10. What's after 2s? Next diagonal line, 2p. How many can p hold? 6. Look at that. 1s2, 2s2, 2p6. 2 plus 2 plus 6 would add up to 10. We used all our electrons. There's our answer for neon. All right, let me do one more example electron configuration, and then I'll do orbital notation. Okay, let's do manganese. For that one, Z is going to equal 5. I'm sorry, Z equals 25. Okay, Z equals 25. So let's go through in order. 1S, and it's going to hold 2. 2S, and it's going to hold 2. Let's go 2P, and it's going to hold 6. Okay, what's after 2P? After 2P is going to be 3S right here. So we're going to have 3S, and how many can that hold? S can hold 2. So 3S2. Every once in a while, you'll take a pause and look at how many electrons have you used. 2, 4, 10, 12. We need to get 25. Okay, next diagonal line. Let's go over here. After the next diagonal line is going to go like this, and we'll do 3P followed by 4S. So let's do 3P. And 3P is going to have 6. Okay, and then after 3P, it's 4S. And 4S is going to have, it's going to have 2. I'm starting to really, okay, here we go. And then after 4S, so I did 4S2, and then after 4S, it's just a tad. After 4S, the next diagonal line goes like this. It's going to go through 3D. So we're going to do 3D. So we're going to have 3D right here. And 3D, let's look at what we've done so far. So we have 2, 4, 10, 12, 18 in total, and we only need to go up to 25. So you're at 18. How many more puts you at 25? Well, that would be 7. So this right here is going to have a 7. Can you even see that whole thing? And now look at how this thing reads. D can go up to 10, but here we only needed D to go up to 7. So that right there would be the whole electron configuration for manganese. Okay. I think what I'm going to do here, guys, I'm going to end the video here. I'm going to edit the assignment so all you're turning in is electron configuration. So if you looked at it at the beginning, it originally it said orbital notation on there. I just think there's so much here for you to absorb. I don't want to make this video any longer because I don't want to overwhelm you. So here's what we're going to do. We're going to stop here. The assignment, by the time it's released on Monday morning, it will only have electron configuration in it. The PowerPoint will only have electron configuration. And this part on orbital notation we'll do as another assignment the next day. All right, so go ahead and submit a picture with those electron configurations. And once you've done that, then that'll be it for today. So hopefully this is making sense. Please email me, contact me if you have any questions. Have a good day.